Hello, my name is Arik Kaderi, and I'm here to present the project we made for our Introduction to Engineering Studies course. My teammates are Nazmul, Shuvo, and Nabir Hasan. We have designed a solar powered smartphone charging station especially for university students, focused on cost efficiency for small universities. Therefore, they can implement it easily and students can get reliable charging solutions. The motivation for our problem was that smartphones are really essential for communication, studying, and handling emergencies. However, the current problem is that charging options are either limited or dependent on electricity grid because um, we don't have enough solar powered or renewable energy sources in our country, which becomes a serious issue during load shedding or power outage. Now the main problem is that solar energy is not constant and direct solar charging can be unstable. Voltage regulation is always required to provide smartphones a viable charging solution. We have discovered the existing solutions, and they were grid connection wall outlets, which are useless because they depend on grid electricity and they are prone to load shedding and can also increase electricity bills. Diesel generators, they have a high fuel cost and also creates noise and air pollutions. Personal power banks, which have limited capacity and the user needs to charge it every time they discharge. Solar chargers with no batteries, these solar chargers without any batteries are very unstable and can be potentially harmful for smartphones. Now we have discovered multiple solutions to this problem. The alternative A was solar with AC inverter. In this system, solar DC power is converted to AC 220 volt and then converted back into DC 5 volt for phones. But this method was rejected because it causes high energy loss during conversion, making it inefficient. The alternative B was direct DC charging without regulation. This method connects the phones directly to the solar panel. However, it was rejected because it creates serious safety issues, especially over voltage, which can potentially damage the phone. Finally, we designed a system that is both highly efficient and provides safe and stable voltage and has 24/7 availability. Now, my team member Nazmul will talk about our system design.
Hello, sir. This is Shuvo. I am contributing this project with system design and calculation and also make the slide. The system starts with an 200 watts solar panel which captures sunlight and can convert into DC power. The power sends to the charger controller. From controller, the energy follows in two directions. It goes through DC to DC converter to ensure 5 volt and also continuously charge the backup battery. The controller prioritizes the charging to the phone fast and then to the battery. Or when the sun goes down or during cloudy day or bad weather, the battery automatically takes over the duty. Analyze and the solution. In this step, we analyze the math. Each USB port needs 5 volts and 2 amperes, which is 10 watts per phone. For 12 phones, our total load is 120 watts. To handle this plus system loss and battery charging, we selected a 200 watt solar panel. This ensured that even when 12 people are charging, we still have some power left over to charging the backup battery. Thank you. That's all from me. Now my teammate will continue the rest of the part.
Assalamu alaikum, sir. My name is Nabir Hasan. I worked on test implementation as a part of this project, and I also written the report. Final step is the implementation design. The system works by channeling energy from the panel to the controller. The controller prioritizes charging the phones, and extra power goes to the battery. If a cloud blocks the sun, the battery instantly takes over. We included fuses and overload protection to ensure that even if there is a short circuit, both the user's phones and equipment remain safe. In conclusion, we have designed a practical campus solution that balances performance and cost. It reduces our reliance on the grid and eliminates the need for polluting generators. These designs represent an optimum solution for a real world engineering problem. And that's all about our presentation. Thank you very much.